Bismillahirrahmanirrahim. Dear students, Assalamu alaikum. Here we have set S whose elements are 1 and minus 1, and here the binary operation is multiplication. We have to check whether this system, that is this algebraic structure, is finite Abelian group. So first of all, we will check the closure property. In this property, we take any two elements from the set. Their multiplication, we see that their multiplication is minus 1, which belongs to S. Hence, set S is closed under multiplication. That is, closure property of multiplication holds in set S. Now, associative law. If we take these two elements and if we take one element from these two, so that we have three elements, if we check the associative property, it is obvious that it will hold also. Hence, this will be the second property which will be satisfied by set S. Now we see existence of identity. Identity is a element which when combined with any other element of this given set, it gives those elements again, that is, it leaves the element unchanged. In this set S, 1 is the identity element. Since multiplication is the binary operation, this identity element is actually multiplicative identity element. It means if we multiply all elements of set S by 1, we get those elements again. Hence, this one is the multiplicative identity. Now we check existence of inverse. Since 1 is the identity element, this 1 is identity element. Now if we take 1, so the product of 1 with 1 is again 1. अगर 1 को हम 1 के साथ मल्टीप्लाई करें तो हमें 1 मिलता है. इसी तरह अगर -1 को, इसी तरह अगर इसी -1 को हम इसी -1 के साथ मल्टीप्लाई करें तो हमें 1 मिलता है. It means that multiplicative inverse of 1 is 1. Similarly, multiplicative inverse of -1 is -1 because their product gives us a identity 1. From these four properties, we say that S together with multiplication is a group. Now we check commutative law. In commutative law, we take any two elements and we check the commutative property. If we take these two elements, then we see that 1 into -1 or -1 into 1, both the product are equal. Thus, commutative law holds in set S. On account of this fifth property, the above group is commutative group. Commutative group is also called Abelian group. Now we check the number of elements. In set S, the number of elements are finite. That is, set S is finite. Hence, the above Abelian group is finite Abelian group. Now we see another example. In this example, we have set S whose members are 1, omega, omega square, where 1, omega, omega square are cube roots of unity. This X represents ordinary multiplication. So we have to check whether set S together with the multiplication is a finite Abelian group. तो इसको check करना है. To check whether the above structure is finite Abelian group, first of all we will check the closure axiom, that is the closure property. In this property, we take any two elements from set S, we multiply those elements and we check whether the result belong to S. So here if we check the multiplication, these two are the element of the above given set S. Their product is equal to omega, which again belong to S. Similarly, the product of these two elements is omega square, which belong to S. Similarly, the product of these two elements is omega cube, and omega cube is the product of 3 cube roots of unity. This omega cube is the product of cube roots of unity. If we multiply these three roots, we get omega cube, and omega cube is always equal to 1. तो जब इसी सेट से हम कोई से दो एलिमेंट आपस में मल्टीप्लाई करें तो उसका वैल्यू सेट एस में दोबारा हमें मिलता है. इट मींस एस इज क्लोज अंडर मल्टीप्लिकेशन. Associative law क्या है? If we take any three elements and if we simplify this one, इन दोनों का ज़रब क्या है? ओमेगा क्यूब है, और ओमेगा क्यूब क्या है? 1 है, और here the product is equal to 1. अब वो इसको हम इस तरह लिख सकते हैं. अब इसी ब्रैकेट को जब हम सिंप्लीफाई करेंगे तो ओमेगा आता है, इन दोनों के ज़रब से ओमेगा क्यूब आता है क्योंकि 1 है. तो here the right hand side both are 1 and the left hand sides are equal. This is the associative property of multiplication. Associative law holds the set S whose elements are cube roots of unity. This set satisfies the associative law of multiplication. Now we check existence of identity. Identity here means multiplicative identity element because the buying operation is multiplication. Under multiplication, one works for identity and one belongs to S. Therefore, identity element that is 1 exists. In this set S, we have the element 1, which is the property. If we multiply 1 with any other element, we get the element again. Hence, 1 belong to S is the multiplicative identity element. Now we check existence of inverse. If we take any two elements from this set, the product of 1, here this one is our multiplicative identity. ये 1 हमारा क्या है? This is our multiplicative identity. If we take element from set S, suppose we take element 1, suppose we check the multiplicative inverse of 1. तो 1 के साथ अगर हम 1 मल्टीप्लाई करें तो हमें आइडेंटिटी 1 मिलता है. दिस इज आवर आइडेंटिटी. हेंस 1 इज द इनवर्स ऑफ 1. अगर हम 1 के साथ 1 मल्टीप्लाई करें तो हमें आइडेंटिटी मिलता है, लिहाजा 1 इज द इनवर्स ऑफ 1. अब हमने अदर एलिमेंट्स को चेक करना है कि 1 का इनवर्स 1 है. अब देखना है कि ओमेगा का इनवर्स क्या है और ओमेगा स्क्वायर का इनवर्स क्या है. Here, this is our identity. यहाँ पे ये हमारा identity है. तो इन दोनों these two are element from set S. If we multiply these two elements, they give us a identity. Similarly, if we take this product, here product is equal to identity. Hence, both these elements are inverses together. The multiplicative inverse of omega square is equal to omega. Omega square is the inverse of omega. That is, both of them are multiplicative inverse of each other. This property can also be written as omega square into omega is equal to 1. This one is our multiplicative identity. तो इन दोनों का ज़रब आइडेंटिटी आता है, लिहाजा ये दोनों एलिमेंट आपस में क्या है? They are multiplicative inverse together. Omega is the inverse of omega square. तो ये दोनों प्रॉपर्टी, these two properties show that omega and omega square are multiplicative inverse together. तो इन दोनों प्रॉपर्टीज को में से अगर कोई एक प्रॉपर्टी हम लिख ले तो हम कह सकते हैं कि ओमेगा and omega square both are inverses of each other. तो 4 प्रॉपर्टीज हमारे पास सेटिस्फाई हो गई. Thus, the algebraic structure S together with multiplication is a group. अब देखना है कम्यूटेटिव लॉ. कम्यूटेटिव लॉ में हम गिवन सेट से कोई से दो एलिमेंट लेते हैं और कम्यूटेटिव प्रॉपर्टी उस पर चेक करते हैं. Here 1 and omega, these are the two elements from set S, and here we see the commutative property of multiplication, which holds each is equal to omega. Here the product of both the element in both the cases equal to omega. Similarly, these two are other two elements which satisfies the commutative property, and here the product is equal to omega square. Here these are other two elements, and this product is equal to this product, and both the product is equal to omega cube is equal to 1. So these three represent the commutative property of multiplication, that is commutative law holds. S together with multiplication is an Abelian group. Set S में क्या है? Since set S contains three elements, set S में 3 elements है, 1 है, ओमेगा है, ओमेगा स्क्वायर है. इसका मतलब ये है कि S क्या है? Finite है. Hence this Abelian group is finite Abelian group.